Hello students, welcome to my channel Engineers Academy. Let's solve these first 5 problems from Engineering Statics by Kraige and Meriam, right? And this is the 7th edition, right? So in this first problem it is said that the force F has a magnitude of 600 Newton, right? So we have this force F which is making 40 degrees with the x-axis, right? And we are required to express this force F as a Cartesian vector, right, in terms of unit vectors I and j, right? So we can write that this force F as a vector can be written as Fx I plus Fyj, right? So Fx and Fy are the components of this force F along x and along y axes, right? So now if we resolve this force F into its components, so it will have one component which will be acting in the positive x direction like this, and it will have one another component which will be acting in the negative y direction like this, right? So this component is known as f of x, since this component is acting in the x direction, right? And this component is known as f of y, right? And you people need to keep this in mind that f of x, we can write that f of x plus f of y, they will always be equal to this force F, right? So now if I add f of x and f of y by head to tail rule, right? So if I place this f of y here, right? So then we can say that this is that f of y force. Let me write that this is f of y, right? So now if we consider this right angle triangle, right? So if I apply cos of 40 degrees to this triangle, right? So if I write cos of 40 degrees, so cos of 40 degrees in this triangle will be equal to base divided by hypotenuse. So base is f of x, so I will write that this is f of x divided by hypotenuse, which is f. So from this we can find f of x component magnitude, right? So f of x is equal to f cos of 40 degrees, right? And from this we can write f of x is f magnitude is known, which is given. This is 600 cos of 40 degrees. So 600 cos of 40, 600 cos of 40. So this is 459.62. So we can say that it is approximately 460, right? So f of x is 460 newtons. And as we can see that this f of x is acting in the positive x direction, so we will write that this is positive, right? This is the positive direction, right? Similarly, if we apply the sine of 40 to this triangle, then according to sine of 40, this will be perpendicular divided by hypotenuse, right? So perpendicular is f of y divided hypotenuse is f. So from this we can find f of y magnitude. So f of y will be f sine of 40 degrees. Again, f magnitude is known, so we can write that this is 600 sine of 40. So if I solve this, so this is 600 sine of 40. So this is 385.67. So we can say that this is approximately 386 newtons. 386 Newton. And as we can see that this f of y is acting in the negative y direction, this is our positive y direction. So we need to write this as minus, right? So this is f of y and it is acting in the downward direction, right? So now these are the scalar components, right? F of x and f of y are the scalar components of this given force, which is 600 Newton, right? And to write this force F as a in terms of unit vectors I and j, so we have to put f of x and f of y in this equation. Let's say this is equation 1, right? So we can write that force F in terms of I and j equals to f of x. So f of x is 460 I plus f of y is negative, right? So I will write minus, and this is 386 j, right? And this whole force units are newtons, right? So from this problem you people need to remember that the component with which the angle is made, right? This force F is making 40 degrees with f of x, right? So we wrote here that f of x is 600 cos of 40. So the component with which the force, the given force, is making angle, then that component will be the cos component, right? So this is 600 cos of 40 degrees, right? And the component which is opposite to the angle made, that will be the sine component, right? So this f of y is 600 sine of 40 degrees, right? So I am telling this is in the coming problems I will not be applying cos of 40 and sine of 40 again and again, right? So I will write 600 cos of 40 and 600 sine of 40 directly, right? Let's say that, for example, we have this triangle like this. Let's say that this is that same f of x component, and let's say this is that same f of y component, and let's say that this is that force F, right? Let's say that this force F is making some angle here. Let's say that this angle is 60. The given angle is this 60 degrees, right? So now from this triangle we can say that this force F, this given force, which is 600 Newton, this is making 60 degrees with f of y. So now if I apply cos of 40 to this triangle, right? So then cos of 60 to this triangle. So for this angle, cos of 60 is this base divided by hypotenuse, right? So now if I write f of y, so f of y is f cos of 60, and again f is 600 cos of 60 degrees, right? So now this is just example, right? So now if the force F, if the given force is making angle with f of y, then this f of y will be the cos component, right? So we can write, without applying cos of 60, we can write that f of y will be 600 cos of 60 and f of x will be 600 sine of 60, right? So you people need to remember this concept. Okay, this is the second problem from 7th edition, right? So let's solve this problem. In this problem, again, we are given this force F, which has a magnitude of 400 pound. So in the problem, it is said that express F as a vector in terms of the unit vectors I and j, and it is said that identify both scalar and vector components of F, right? So now if we resolve this force F into its components, so this force F is making 30 degrees with the horizontal, right? So again, is if I draw the components of this force F, so it will have one component which will be acting in the negative x direction like this, right? And it will have one component which will be acting in the positive y direction like this, right? And this component is parallel to the x-axis, so we can write that this is f of x component, and this is parallel to the y-axis, so we can write that this is f of y component, right? And you people need to remember that the summation of f of x and f of y by head to tail rule will always give us this force F, right? So remember that f of x, the summation of f of x plus f of y using head to tail rule must always gives us that force F, right? So now if I add f of x plus f of y, so they will give us this force F by head to tail rule, right? So I can write that this is my f of y. So now if we consider this right angle triangle, and again if I apply cos of 30, so cos of 30 is perpendicular divided by hypotenuse. Sorry, it is the base divided by hypotenuse, right? So base is f of x and the hypotenuse is f, right? So we can write that f of x is equal to f cos of 30 degrees, right? And f of x is, so f magnitude is 400 pounds, so 400 cos of 30 degrees, right? 400 cos of 30. So this is 346.41, right? So we can say that this is approximately 346 pounds. So f of x magnitude is 346 pounds, and this f of x is acting in the negative x direction, so we have to put minus sign here as well. So this is minus, right? So now you people need to remember that whenever the given force is making angle with f of x, then f of x will be the cos component, right? So now from now onwards we will use f of x directly as f cos of 30 degrees, right? And similarly f of y will be the sine component, right? So f of y is f sine of 30 degrees, and it is acting in the positive y direction, so we have to write plus, right? So f is again 400, so 400 sine of 30 degrees, 400 sine of 30 degrees, so this is 200, right? So f of y is 200 pounds. So now to express this force F as in terms of unit vectors I and j, so we can write that this force F will be equal to f of xi plus fyj, right? So then we can write that f of x is minus 346 I plus 200j. So this is the force F in terms of I and j vectors, right? So this is also known as the Cartesian vector representation of this force F, right? Now let's solve this third problem. So in this third problem, it is said that the slope of 6.5 kilonewton force F is specified as shown in the figure, right? So the slope of this 6.5 kilonewton force is given in the form of this triangle, right? So it is said that express this force F as a vector in terms of unit vectors I and j, right? So now if I extend the line of action of this force F, let me extend the line of action of this force F, right? So this force F is intersecting the x-axis at this point, right? So let's say that this force F is making some angle theta here, right? So this theta and this theta will be equal, right? Since the slope of this force F is given in terms of this triangle, right? So now we can find this theta by using tan theta, right? So if I apply tan theta to this triangle, then tan theta is equal to perpendicular divided by hypotenuse. So we can write that theta is equal to tan inverse 5 divided by 12, right? So we can find that angle. So this angle is 22.62 approximately, right? So we can write that theta is 22.62 degrees, right? So this means that this 6.5 kilonewton force is making 22.62 degrees with the positive x-axis. So now we can resolve this force F into its components, right? So it will have one component which will be acting in this direction like this, right? So we can place it here as well, right? And similarly this force F will have one component which will be acting in the negative y direction like this, right? And these two forces by head to tail rule must give us this force F, right? So if I add both of these components, so they must give us this force F, right? So this is f of y component and this component is f of x, right? And we know this angle, right? So this angle is theta. So now from this triangle we can say that the angle, the force F is making angle theta with f of x. So we can write that f of x is the cos component directly. So I will write that f of x is f cos of theta, and this f of x is acting in the negative x direction, so I will write minus, right? This is minus f magnitude is 6.5 kilonewton cos of 22.62. So this will give us the f of x magnitude 6.5 cos of 22.62. So this is 5.99. So we can say that this is approximately 6 kilonewton, right? So we will write that this is minus 6 kilonewton, right? So this is f of x. Similarly, we can write f of y. So f of y will be the sine component, right? If this is the cos component, then f of y will be the sine component, since f of y is opposite to this theta angle, right? So we can write that this is f sine of theta, and f of y is also acting in the negative y direction, so I will write minus. So this is equal to, so minus, and f magnitude is again 6.5 sine of 22.62 degrees. So this is 2.5, right? So we can write that this is minus 2.5 kilonewton, right? So we can represent this force F as a Cartesian vector in terms of unit vectors I and j. So F vector will be equal to F of xi plus F of yj. So F of x is minus 6i, and this is minus 2.5 j, and we can write that the units are kilonewton. Okay, now let's solve this 2-4 problem. So in this problem, again it is said that again we are given this force F and we have to determine the scalar components of this force F. But in this problem it is said that the line of action of 3000 pound force runs through the point A and B. So the line of action of this given force is passing through these 2 points, right? And we are required to determine the x and y scalar components of force F, right? So we have to find the magnitude of f of x and f of y, the components of this force F along x and along the y axis, right? So now we are given this A and B points, and we indirectly we are given that angle theta of this force F with the horizontal, right? So if I draw a line here parallel to the x-axis, right? So let's say that this force F is making some angle theta, right? So if I draw another line, so theta is the slope of this line, right? So we can say that theta, if you want to find this theta, let's say that somewhere here the intersection, this intersection point is, let's say, point C, right? So if we apply tan theta to this triangle in terms of lengths, right? So I can write that tan theta is equal to BC, this BC length, this perpendicular, divided by this AC, right? So this means that this tan theta is the slope of this line, and this BC is the change in y coordinate, right? This BC is the change in y coordinate, and this AC is the change in x coordinate, right? So what is the meaning of change in y and change in x, right? So we can find, let's say that the coordinates of this point A are, let's say this is x1 and this is, let's say, y1, and let's say this is x2 and this is y2, right? So change in y will be y2 minus y1, and similarly the change in x will be x2 minus x1, right? So we can find this theta, right? So let me write that this tan theta is equal to y2, so y2 is 6 minus, and y1 is minus 2, right? So I will write that this is minus 2, and similarly x2, so x2 is 8 minus, and x1 is minus 7, right? So I will write minus 7. So we can write that tan theta is 6 plus, this is 2, and this is 8 plus 7, right? So if we take tan inverse, so theta will be equal to tan inverse, and this is 6 plus 2 is 8, and this is 15, right? So this will give us theta angle, right? So tan inverse 8 divided by 15, so this is 28.07, right? So theta is 28.07 degrees. So this means that this given force is making 28.07 degrees with the x-axis, with the horizontal, right? The line which is parallel to the x-axis, right? So now if we resolve this force F into its components, so it will have one component in this direction like this, and similarly it will have one another component which will be acting like this, right? So this is f of x, and this component is f of y, right? And as this theta is made with f of x, so f of x is the cos component, right? So I can write directly that f of x is f cos of theta, right? F magnitude is 3000 pound, so I will write 3000 cos of this angle, which is 28.07, right? This is f of x. Similarly, f of y will be the sine component, right? So f of y is f sine of theta. So f is 3000 sine of theta. So theta is again 28.07. 3000 cos of 28.07. So this is approximately 2647, right? So f of x is 2647 pounds. And similarly, this is 3000 sine of the same angle. So this is 1412, right? Approximately, right? So this is 1412 pounds, right? So this is the solution of these 4 problems. The solution of the 5th problem is given in the description, right? So I will give a link for that 5th problem, right? So you people can click on that link and find the solution of that particular 5th problem.